Hello guys, welcome to my YouTube channel. Today we are going to discuss the simulation for bolt bearing joint due to cyclic loading. We are going to create this bolted joint in Abaqus and we'll be generating this force displacement curve, which you can see. This force displacement curve is generated due to cyclic loading. First thing which you need to do is you need to create all these parts, which is bolt, bottom plate and the top plate. Once you've created all the parts, so like here you can see this is the bottom plate and then this is the top plate. If you want, you can create this kind of shells over the plates and also over the board to have good meshing for the complete structure. This is the property you can see. The property is steel, so steel density, elastic property and the plastic property I've given. So if you want, you can give all these details. Density is basically not needed for static problems, which we are doing here, but if you want, you can go ahead with it. Next, once you've created the property, assign the section. You have to come to the assembly, assemble the part. You can see this part is assembled. The top plate, bottom plate, and bolts. Once you are done with the assembly, you have to uh, create steps. All the steps with nonlinear geometry on. So in the first step, you are going to provide the preload to the bolt, and the second step, which is dynamic, implicit here. So that's why the density was there. So this is dynamic implicit problem, but you can go for the static also, not an issue. So if you're doing an dynamic implicit problem, you have to give the density. So here you can see these are the steps which are created. Once you go to the steps, next is the interaction. You have to create the interaction. That means you have to give the property. So you can see here property is given. Penalty method is used, tangential normal behavior, frictional options, all these things are added. Next you go to the load. You In the load you have to give the boundary conditions, you have to give the preload. So here you can see here the load is applied and I've given a cyclic loading. You can see this amplitude table here. Here is the cyclic loading which is applied, and this amplitude is given in a tabular form, which is here. This is the maximum amplitude of which is applied to the plate. Another plate this side is fixed, so it will remain fixed throughout. You can see here, and the preload is applied over the bolt, which is of 1000 newtons. Uh, Regarding amplitude, you can see the amplitude which I created. This is a sinusoidal tabular in the tabular form. You can see this is the uh, data, the table which was created. Uh, Next, once the load is created, go to meshing. Mesh the model. You can see how nicely the mesh is created. The circular mesh, even on the board, the mesh is very nice. You can go to the parts and see the mesh. Nice mesh is created over the bolt, and similarly, very good mesh over the plates. Once the mesh is created, go to job and submit the job. You want to see the results, go to the result, and you can clearly see yes, this one. You can see the plate moving. Here you can see how the plate is moving slowly and the bolt is getting beared. Bearing load is applied over the bolt, which you can see here clearly. Okay, now how to generate the force displacement curve. So for that, you have to uh, go to the field output, select unique nodal, select reaction forces in the direction, which direction it is. Load is applied in x direction, so you have to calculate the reaction forces in x direction. Area selection by angle, select all the nodes of the fixed plate. Done. Save it. So it will give you the reaction forces at each node. But you want a total reaction force. Operate an XY data. You have to go to the sum. Basically, you need to add sum. Save as XY data. You can write it as force. Okay, yes, it's saved. You can delete all other points because it will create a lot of confusion. Delete. Here you go, this is the force. Next you need a displacement. So take any point, any node on the face where you apply displacement. And you have U1 here because we want displacement in direction 1. There's only one node we need. So take this node, done, save as. Next thing is now we need to use combine to plot, operate on XY data. Now we need to go to combine. You have to select displacement, you have to select force, and just give a negative sign here. Plot the expression. Here you got a force displacement curve, which I was talking about. Thanks for watching this video. Please explore my channel to see more video on simulation.